Hi, everybody. Good morning. Today is Monday, February 12th. And let's see. Okay. So, today you have homework 3 due. So, homework 3 covers 7.4, 7.5, and 7.6. And remember, you need to submit your first attempt by midnight. After the deadline, you can continue to work on your homework to improve your scores. And remember how to find your homework. So if you're in a student view, if you see click assignments, then if you have like show by date, then you only see the homework 3, right? But it's actually down there, up undated assignments or past assignment is actually in the past assignments if you still want to work on homework 1 and homework 2. But you can always click show by type, then you can see all the homework by the types. Okay, so that's the homework. And the exam is on next Wednesday because Monday I need to help with the Select 8 events. So many prospective students gonna come to our school to see, our different degrees, see our labs, and so I'm gonna help with them. So I cannot say after class. That's why we moved to Wednesday. But Monday, I have my previous class. I teach applied trig in this classroom from 9 to 9:50. So if they need extra time, they will just continue and work on their exams here. So don't be surprised. Just come in and we start and continue to our class. Okay. So when they finish, they will give me their exams and leave. Okay. So that's the plan. Ooh. Because we postponed the exam 1, do you want to move the homework 4 to next Monday? Yeah? Maybe that's better. So, okay. Uh, we move homework 8.1 and 8.2 and the quiz here. Okay. So you can do your homework over the weekend and be prepared for the quiz. Okay. So, yes. I would say in the meantime, so before our exam 1, because we postpone our exams, so we do cover new stuff like 8.1, 8.2. So yeah, if you have a chance, work on your homework. So the quiz, okay, is on now February 26th. The quiz, I need to change the date in Canvas. The homework, we might not able to, we don't need to change the homework because the late day doesn't affect your grade, but the quiz is so important. So let me change the quiz. Oh, I need to leave student view first, then I can change the quiz due date. Okay, so the quiz due date. Yes, so the quiz is now Monday. Okay. All right, and is available on Monday. Okay, and save. Okay, so now quiz 2 is on Monday. Okay. Right. And that is our updated class schedule. Okay, and so you expect this week you're gonna have 2 homework set to. Okay, yes. All right, so let's continue. So last time we talked about integration by parts. It's like the product rule for derivative, right? It's like the product rule for derivative, but product rules works for all types of different products. The integration by parts method only works on some type of products. Okay, it does not work for all the integrals. Okay, and what we do is, remember the formula? Let's read it again. Integral u dv, everybody read it, equals uv minus integral v du. Again, louder. Integral u dv equals uv minus integral v du. Close your eyes. Integral u dv equals uv minus integral v du. I have your phone number. I can call you at midnight. Hey, wake up. What is the integration by formula? Okay, so we want to differentiate the u and we want to integrate the dv. So u is something we can differentiate and make the problem easier. So dv is something we can integrate and then the problem is not getting so much harder. So example 1, part A. Last time we looked at, natural log of x. We only know the derivative. Do we know the integral? No, that's why we're looking for the integral, right? So we can only differentiate it, then let it be u. If we can only differentiate it, let it be u. Then dv is the remaining. So the remaining is dx. Now, we want to find du. The derivative of natural log of x is 1 over x dx. And then we want to integrate the dv. So integral of 1 dv is v. Integral of 1 dx is x. This is the part you don't need to plus c. Okay, everybody? We don't need plus c here. Then we just directly apply the formula. So uv minus integral v du. And then we realize, the x cancel. Integral of 1 is just x. And then we have plus c at the end. Do you still remember that, everybody? Mm-hmm. So now let's continue. Okay. Let's see. So u is something we want to differentiate and make the problem easier. So then let's see. Part B. Okay. So u, we have two types of functions, x and e to the 3x. Let's think about it. If we let u be x, what is du? If we let u be x, what is du? What's the derivative of x? 1, right? So du is just dx, right? So the power drops down by 1. And then the remaining is dv. dv is e to the 3x. What is the integral of e to the 3x? 1/3 e to the 3x, right? So it's still exponential function, but the good thing is now we have the x power drop down by 1. Okay, but if we do the opposite, if we let u be e to the 3x, then du is 3 e to the 3x, still exponential function. But the dv is going to be x dx. We need to integrate the x. It becomes x squared over 2. Right, everybody? You see x squared over 2? The power increased by 1. We make the problem harder than we thought. Okay, then it begins. So sometimes if you're not sure which one we should let u to be, you can try both and you see which one work. Okay, maybe it's better for me to write it down both, and now you can see the difference. So the first one is we let u be x, and then dv is the rest. Is that okay, everybody? We let the u be x, and let the dv be the rest. E to the 3x dx. What is du? 1 dx. Okay, attendance. Thank you. Okay, what what is the integral of e to the 3x? E to the 3x over 3. Yes. Okay, good. So after we figure out the du and the v, we can use the formula. What is the integration by parts formula again? U, what is u? X. And then? Integral. U dv equals u. Yeah, v. 1/3 e to the 3x minus what? Integral v. What is v? 1/3 e to the 3x du. Sorry, dv. What's dv? Sorry, no, du right here. Yes. Integral of u of v du. So du is dx. Right, everybody? uv minus integral v du. Oh, you see? This integral is easier. Our power of x dropped down by 1. Can we integrate this guy? Yeah? Just the power. That's the exponential function. Yeah, we can integrate that. So that is 1/3 x e to the 3x minus, what's integral of e to the 3x? Is 1/9. Very good. Okay. Yeah, because I see the screen, the lights is turning down. So, I forget to charge my laptop. Okay, so 1/9 e to the 3x plus c. And that's the answer. Okay, everybody? So now I want to show you what happened if we pick the wrong u. Okay, so if we pick the wrong u, if we let u be e to the 3x, then the remaining be dv. You see the derivative, the du is 3 e to the 3x dx. So in this process, you're going to be very careful and slow down because you need to do derivative and you need to do integral, right? So it's very easy to confuse and mess up the formula. So slow down. So what are you doing? Are you taking the derivative or are you integrating it? Okay, so what is v? What's integral of x? Integral of x is, yeah, x squared over 2. Now you see uv. uv is, u is e to the 3x. v is x squared over 2 minus integral v x squared over 2 du 3 e to the 3x dx. Do you see this integral? We have x squared e to the 3x. It's harder than we start with. Yes. So this is harder. If you end up getting a harder integral, that means your u and dv, they're wrong. You picked the wrong one. Okay? Then just choose a different u and dv. Is that clear, everybody? Doesn't hurt to try. You know, math, you try. It's like we're driving. If you see a dead end, what do? You go back and find other way. Do you hit the dead end, hit the house, or hit the seat? No, we go back and try other way. Yes. Okay, let's continue. Okay. So let's see. Oh, okay. So now part C. We increase the power of the x. So sometimes, bless you, you might need to do integration by parts twice or 3 times. Okay, and then the power of x dropped down by 1. Yes. So here you will have x squared. We might need to do integration by parts twice. Okay, so let's see. What is our u? Yeah, x squared. So this example tells us that if you see power function times exponential function, we always let u be the power function because your power drop down by 1 after you differentiate. So we'll make the problem easier. So u is x squared plus u. dv is what? Oh yes. So dv is e to the 3x dx, and du is 2x dx. Good. Now what is v? Yes, very good. Right, everybody? Mm-hmm. So what is the integration by parts formula? Integral u dv equals integral u dv equals u v. What is u? What is v? Yes, and then minus integral what? V du. Yes, everybody? Yeah, so say it loud. Say it 10 times. So you can remember. uv minus integral v du. Mm-hmm. Let's put all the constant coefficients in front. So we have x squared e to the 3x. And then minus the 2/3, move it in front. Do you see we have x e to the 3x? dx? Yes, everybody? Oh, this is exactly the last problem. Right, everybody? That's exactly the last problem. So we do integration by part, which we already did. And we got that answer. So you just replace that answer here. Is that okay, everybody? Mm-hmm. Yeah, we did that. So sometimes you need to do integration by part 2 times. So we replace that. We get 1/3 x squared e to the 3x minus 2/3 times, what is that? 1/3 x e to the 3x minus 1/9 e to the 3x plus c. We replace that integral by let's simplify it. Let's multiply it out. Everybody finish this part? Mm-hmm. Okay, yes, let's distribute. We get 1/3 x squared e to the 3x. We distribute. What do we get? What's 2/3 times 1/3? Don't be shy. Tell me your answer. 2/9 x e to the 3x. And then how about the next term? Plus or minus? Plus what? Yeah. So 2 and then over what? Yeah, 27. And then e to the 3x. And the c, you could just say plus c. It's still a constant. Okay? You don't have to do minus 2/3 c. You just leave the c there. It's constant. Or if you like, you can call it d. Like rename a different constant to you. Okay? So this is the answer for part C. From this example, you can see sometimes we need to do integration by parts uh, 2 times. All right. Any questions so far? All good? Okay, now it's your turn. Do part G. Everybody do part G. What is your U? What is your G? Be careful. So if we see power function and exponential function, we always let u be the power function. But if you see power function and natural log, what is your u? Okay, questions. Can you differentiate natural log? Yes. But can you integrate natural log? No. So natural law has to be because we're not able to integrate it. I'm looking at why is this like here? Oh, but if you go to the website, there's a whole PDF that you can do. Oh, so you cannot upload a whole PDF? Oh, oh, I see, I see. I thought you can do it on I could hold it. But this app you cannot upload it. Yeah, this one didn't. Mm. Oh, I know how to do. So maybe you can go to our website and can you print screen? We can print screen.
Mhm.
Then the print screen, yeah. Because I'm seeing you can see the backside.
Yeah.
So this is called the differential. When two kids play on the seesaw, we eat on both sides. Good. So now you can combine. Now how many x power? Oh, C. Oh, du. So 1 over x dx. Right. Okay, now so that x power, right? We can combine them. So I put the constant in front of it to go and power. Combine the x power. Put the coefficient in front of the integral. Put the number in front of the integral, and then x. So that is the power. Yes. So, the coefficient you have. Oh, you remember you integrated, so you add 1 to the exponent. So it was 11 plus 3. Yeah, so 14. Is it 14? Oh, then this guy also okay, yes. So, yes. So, no, yeah, because you divided by, yeah. Now you can integrate this using power rule. Yeah, good. UV minus integral V du. Oh, no, after you integrate the all right, let's check our answers. So this is 8.1. Okay. All right. So all you have to do is natural log of x, right? then the dv is the remaining x to the 11 third dx. And then the derivative of natural log of x is 1 over x dx. The v integral of that, add 1 to the exponents, x to the 14 thirds over 14 thirds, the third, flip it upstairs, right? And then integral of u dv is uv minus integral v du. Okay, so v is here, du is here. So if you want to look at the picture, it looks like this. It's uv minus integral v du. Yeah, exactly. Okay. And here, this part, move the coefficient in front of the integral. And then combine the x power. So this, because divided by x, is like the exponent, subtract 1. Right, everybody? So subtract 1, x to the 11 third. And then we integrate, we add 1 to the exponent. It becomes 14 thirds, and then over 14 thirds. So it's like 3 over 14 squared. So this is our answer. Any questions about part G? So we integrate that. Yeah. We get x to the 14 thirds over 14 thirds. It's the same as multiply by 3 and divided by 14. 3 squared is 9. 14 squared is 196. Okay, so products rule for derivative, it works for all types of products. But integration by parts, based on the knowledge we learned so far, it only works for, I should say 2 cases. Okay, so we distinguish in 2 cases, not 3. Okay. Yes. Okay, that's 2 cases. Okay, so if you see power function times exponential function, then you let u be the power function. Okay, and the rest is dv. If you see power function times natural log, then you let the u be the natural log. Okay, because the natural log you can only differentiate, you cannot integrate it. So you let u be the natural log, and then dv is the power function. Is that clear, everybody? So just 2 cases. Okay, how about here, yes, that's 2 cases. Okay, the formula for integration by parts when we have definite integral, I would say just find the indefinite integral and then plug in the values. So let's see example 2. Let's find the indefinite integral first. Then we plug in the values. Okay, so for the indefinite integrals, so that is one indefinite integral, we move the bounds. And then this is like 5 natural log of x plus 2. And then this is like 1 over x to the 4th dx. Multiplication. Right, everybody? By the way, if my problem is like 5 ln x plus 2 to the 4 over x, if the 4 power is on top of the 5 ln x plus 2, then what method do we use? What method do we use? What method we learned? Substitution. U substitution. Okay, so that if we have the 4 power on top there, we do u substitution, and we let u be 5 ln x plus 2, and then du will be 5 times 1 over x dx. So then this part is going to contribute to the du. Is that clear, everybody? But now, because the 4 power is okay, everybody? Because if you want to try to use u substitution, I only need 1 over x. I don't need 1 over x to the 4th. 1 over x to the 4th is not our u. The u z y, we cannot use the u substitution here. Yes, so the u substitution is so limited. We have to see the du. Okay? So that's why here we need to use integration by parts. So u is the expressions involving the natural log of x. So in this case, u is this. So let me draw it. U is 5 ln x plus 2. And then the remaining is dv. By the way, 1 over x to the 4th is x to the what power? X to the what power? Negative 4. Yes. So x to the negative 4 dx. Okay? If you see power function times natural log, always let u be the natural log. And then your dv is the power function. What is du? What is the derivative? Yeah, 5 over x dx. Right, I also put it here. Right, when we try to use substitution, you put it there. How about the integral? What is the v? What's the integral of x to the minus 4? X to the negative what? Well, you add 1 to the exponent. Negative 5? Add 1. Negative 3, yes. Over negative 3. So when you work with the negative exponents, or if the power function is in the denominator, make sure you change to the standard form. So you have x to the some power. And then that exponent plus 1. Okay. So then that integral u dv is uv minus integral v du. If you kind of write down the formula first. Then we plug in. U, what is U? Yes. What's V? Negative. So it's x negative 3 over negative 3. Right, everybody? And then minus integral of V, which is x to negative 3 over negative 3 times du. So 5 over x dx. Is that okay, everybody? All right. What is that? Okay. We have negative 3 downstairs. And we have 5 ln x plus 2. And we have, you can put the x cubed downstairs. Okay. After we integrate, we can simplify it. And now, do you see we put a coefficient in front? The minus become plus. And we get 5 over 3. Yes? So minus cancel 5 over 3. Put it in front. And what is the x power? X to the what? Negative 2 or negative 4? Yeah, right, everybody? It's negative 4 dx. So that is negative 5 natural log of x plus 2 over 3x cubed. And then what is the integral of x to the negative 4. X to the -5? Yeah, -3 over -3. Yes. Plus C. Good. So that's why the answer for indefinite integral is -5 ln x plus 2 and then 3x cubed. And then, you see, that's become minus 5 over what? 5 over 9, right? And also the x cubed is also downstairs. Is that okay, everybody? So, but now we are computing the definite integral. So 1, 2, 3. Can I just put dot, dot, dot? And can I also put, is this guy evaluate from 1 to 3? Can I do that, everybody? No? No, okay. So we're calculating the definite integral. So it's just this antiderivative, we evaluate from 1 to 3. Yes. So instead of writing down the whole thing, okay, put a dot, dot, dot here. Then now we plug in. So we plug in 3 first. So minus 5 ln 3 plus 2. And then over 3 times 3 cubed. Yes, we plug in 3. Minus 5 over 9 times 3 cubed. Is that okay, everybody? And minus, okay, parentheses, -5 ln 1 plus 2 over 3. What is 1 cube? 1 cube is just 1, right? And then minus 5 over 9. 1 cube is also 1. Oops, sorry. Okay, so this is what happened when we plug in 1. Is that okay, everybody? We plug in 3 minus parentheses when we plug in 1. What is ln of 1? ln of 1 is 0, right? Natural log and natural log of 1 is 0. So that's why here we just got 2/3. And the minus, it changed the minus to plus. And when you distribute, it also changes. Yeah, put this in your calculator. What do you get? One point 1091. Oh, I did the answer. Did you get a number? 1.2. 1.2 something. Different number. Okay, let's do this. The amount of parentheses was very easy to make difference.
Did she also got with it?
Point 9241. Oh, we got 4 different answers. 1.2. What do you get? Syntax error. Okay. So maybe the parentheses are right. What do you get?
I got the same thing.
Oh.
109.
1.109. Okay. 1.109. Okay. I got like 2.257. but I may get a mistake.
When we have test, can we just do like, can we just count if we get the format right?
Hopefully your test will be. But if you get this right, I would probably say you will get all the points. So yes, that's why show your work. Okay, so show your work. If I see this part you get it right, I'm gonna give you all the points. So in the exam, show all your work.
As long as you have everything right down.
Yeah. Have everything right down. Exactly. Oh, last week did we look through the practice exam and see what type of problems on the practice exam? Okay, good. Okay, yeah. So keep working on the practice exam. If you have questions, feel free to ask me. And if you want to meet me in the evening, we can certainly do that. So email me, then we can go to the big blue button together. Then you can share your screen and you can ask me questions. Okay? Yes. So when is our exam? Next Wednesday. And do your homework and the practice exams. Bye. Have a good day. And you are on Monday, 11:40, right? Yeah. Yes. Okay. Yes. So don't ask Blaine what's on the exams. He won't tell you. Okay. Bye, Patrick.
Bye-bye.